All right, today's lecture, we're going to be looking at chapter 3.1. We're going to investigate the Cartesian coordinate system. All right, so you probably already know what a coordinate plane is, but we're going to explain it regardless. So we have what we call an ordered pair, and we label it as x, comma, y, because on a coordinate plane, this is your x-axis, and this is your y-axis. So if I have an x comma y, I know how far I need to go on the x and how far to go up on the y. On a coordinate plane, this is what we call the first quadrant, second quadrant, third quadrant, and then the fourth quadrant. So you can see that it makes a C for Cartesian or coordinate plane. So it goes 1, 2, 3, 4 when talking about which quadrant you are in. And that's, oh, we'll also be talking about once we're on the coordinate plane and we have 2 points, how to. So the distance formula is d equals the square root of x2 minus x1 squared, y2 minus y1. Difference of x. Or whatever the is all going to be about taking the difference. I was to switch this and say x1 minus x2, and I got a negative number versus the positive number that you should get. When you square it, everything's going to be positive anyways. So when it comes to the formula, just know you just got to find the difference of your x's and the difference of your y's, square them, and then add them up, and then take the square root of that result. So don't stress too much about, oh, is it the second one? So the other formula you need to know is your midpoint formula is x1 plus x2 divided by 2 and y1. So again, adding your x's, divide them by order, but you're just adding your matter. Just make sure you keep your x's together and your y's together. Other than that, pretty much it for 3.1 in their notes. So let's do some practice problems, the assignments. All right, so we'll start off with question 1 on page 164. This one says, just plot the following sets of points in the Cartesian planes. The points -3, 2, 5, -1, 0, -2, 3, 0. So here's my coordinate plane. You would provide it one on a nice cleaner one. If I want to graph this one, I start with the x value and then I go to the y value. So negative means I need to go to the left. So it's 1, 2, 3. A positive y then means I go up. So 1, 2. So here's my first point. Then I do the next one. A positive x value means I go to the right. So 1, 2, 3, 4, 5. And then a negative y tells me I need to go down. So then that's 5, -1. I have 0, -2. So 0 tells me I don't move at all. Then the second number being -2 tells me I need to go down 2. So there's my third point. 3, 0. So I'd go right 3. A y value that's 0 tells me I do not go up or down either. So I would be right there. One. I got the a lot of stuff happening there. All right. Should be just about, let me just plug this up. Things that you can't technically see when you're watching the video, but there's a lot of technology and chords going on here. Just trying to, I don't like the delay. You might not see it, but it's like a almost a 1.5 second delay from what I'm writing versus what's showing up, which throws me off as I'm trying to talk to you as well. All right, so hopefully that takes care of a lot of those issues. But again, you just start with the x value, then go to the y value. X is left and right, y value is up and down. For x's, again, positive is right, negative is left. For y's, if it's positive, it's up, negative, it's down. If it's a 0, that means you did not move in any direction according to either the x or the y. All right, so let's move on to something a little bit more complicated. So let's look at number 9. It says identify the quadrant in which each point lies, if possible. If a point lies on an axis, specify which part, positive or negative, and which axis, the x or the y. So here we go. So number 9, you're given -2, -4. So that means I go left 2, down 4. So there's my point. Remember, the quadrants go 1, 2, 3, 4. So I can see quadrant 3 is where my coordinate falls. You can also look at it looking at the signs as well. Quadrant 1 is positive, positive. The x and y are both positive. Quadrant 2, it's negative and positive. So the x value is negative, but the y value is positive. Quadrant 3 is negative, negative, as we can see with -2 and -4. And then quadrant 4 is positive, negative. So the x value is positive where the y value is negative. Right? Just a little idea depending on what kind of question you get. All right, let's get again, try to make it a little bit more complicated. Let's look at number 27. So for this set, it says for each of the following equations, determine the values of the missing entries in the accompanying table of ordered pairs, then plot the ordered pairs and sketch your guess of the complete graph of the equation. So 27 says 6x minus 4y equals 12. And we have a incomplete table that we need to fill out first. So we have 0 and something. We have something and 0. We have 3 and something. And then we have something and 3. All right. So here's the best way to approach these type of problems. Plug in what you know, solve for what you don't. So for this first one here, it's going to be 6 times 0, since I know x is 0, minus 4y equals 12. Well, 6 times 0 is 0, so that just goes away. So all I really have to do is divide by -4. So I see y is -3. So this would be 0, -3. Do the same thing with the y value. So this time it's going to be 6x minus 4 times 0, because this time I know y is 0, equals 12. Again, that will 0 out. So all I got to do is divide by 6. So x equals 2. So this would be 2, 0. Do the same thing with the 3. I would then do 6 times 3 minus 4y equals 12. This time I got to do a little bit more math. 6 times 3 is 18. And then I would subtract 18. 12 minus 18 gives me -6, divided by -4. And I'd get positive 3/2. If you have to write it as a improper fraction, 1 1/2. If you have to do it a decimal, 1.5. Just make sure you pay attention to what the directions are asking on how it wants their answer. And then we're just going to do this one more time. This time the y is 3. So this would be 6x minus 4 times 3 equals 12. Well, this right here ends up being 12. So then get rid of this, I would add 12. So then I get 6x equals 24. Divide that by 6. I get x equals 4. All right, and there you go. So then the next part is they want you to graph it. So we have 0, -3. There's my first point. 2, 0. So again, look, I go straight back to the origin before I start. So 2, and then 0. So here's the next one. Then 3 and 1.5, which would be about right here. And then I have 4 and then 3, which would be about right here. And it simply just says plot the court, sketch your guess of the graph. So here's my guess of what the graph's doing. I'm going to assume it's probably doing something along this lines. Right? So I think on yours, you would just connect the dots and it would make a sketch for you. All right, let's do some more of those. Let's look at number 28. So I have y equals x squared plus 2x plus 1. My incomplete table here is don't know my x, y is 0. X is 1, what's my y? Don't know my x, but now my y is 1. 2 is my x, don't know my y. And then -3 is my x, don't know my y. All righty. So again, you just start off with what you know. I know y is 0, so this first one, it's going to be 0 equals x squared plus 2x plus 1. This happens to be a quadratic that you can solve that we did in chapter 2. So I'm going to work on factoring. So that again, a trinomial fraction in two binomials where the leading term will always be x. Two numbers that multiply 1 but add up to 2 happen to both be positive 1. When I set both of these equal to 0, I get x equals -1 and x equals -1. So I happen to only get one answer. All right, so then I keep going. So now I'm going to look at, all right, what happens if x is 1? So here we go. So y equals 1 squared plus 2 times 1 plus 1. So that would give me 1 plus 2, which is 3 plus 1. So again, this is 1 plus 2 plus 1, which gives me 4. So I get 1, 4. Then I do it again. I see y is 4 this, sorry, my bad. Y is 1 this time. So that would be 1 equals x squared plus 2x plus 1. We always have to set quadratics equal to 0 to solve them. So I subtract 1. And so now I get x squared plus 2x. Oh, that cancels 2. So then I factor. So this ends up being x plus 2 using the greatest common factor. Set them equal to 0. So x equals 0 and x equals -2. So I get two answers, 0 and -2. So this would be 0, 1 and -2, 1. Right? So this will give me 2 points right there. Then we do the next one. So the next one is, let's say x is 2. So now I get 2 squared plus 2 times 2 plus 1. So it's going to be 4 plus 4 plus 1. So that gives me 9. Try it again with -3. So we get y equals -3 squared plus 2 times -3. Notice I'm using parentheses. This helps me indicate that I'm doing multiplication, and this helps remind me that this is a negative being squared. So -3 squared would give me +9. 2 times 3 is -6 plus 1. So that's 3 plus 1, which is 4. All right, so there we go. So then we have our points. Now we can sketch our graph. So we have one at -1, 0. So that's right here. Then we have one at 1, 1, 2, 3, 4. Then we have one at 0, 1. And we have one at -2, 1. So we have the next point right here. Then I have another one at 2, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have one at -3, 4. So 1, 2, 3, 4, give or take right there. So seeing what I see, I'm going to assume I'm going to sketch a graph that looks roughly like this. So I know a quadratic is going to make a U shape. So I'm assuming I'm making some type of parabola. All right, let's do some more. Let's look at number 29. 29 says x equals y squared. And we have our incomplete table. So this will be 0 unknown, 1 unknown, 4 unknown, 9 unknown, ooh, and then unknown -square root of 2. So let's work through it. So I get x equals Oh, I lied. This will be 0 equals y squared. To get rid of a square, we just take the square root, but don't forget the plus or minus. Now this happens to just be 0 because there is no plus or minus. So then I move on to the next one. So now I have 1 equals y squared. Take the square root, don't forget the plus or minus, so I get plus or minus 1 equals y. So I get a positive 1 and a negative 1. So those are 2 points there. Then I move on to the next one. I get 4 equals y squared. So take the square root, don't forget the plus or minus. Square root of 4 is 2, so this is plus or minus 2 equals y. So again, 2 and negative 2. Don't know exactly if it's positive or negative, so I have to account for all of these different points. So then I move on and I do 9. We do 9 equals y squared. Take the square root, plus or minus. This gives me plus or minus 3 equals y. So this is going to be 3 and negative 3. All right, last one. This time I don't know the x, but now the y is negative square root of 2 squared. Well, a negative squared will be positive, and then the square root and the square will cancel. So I'm really just left with x equals 2. So there is our ultimate answer. So let's graph that and see what's going on here. So I got 0, 0. I got 1, comma 1. I also have 1, comma negative 1. Then I have 2, 3, 4, 2, and 2. So then I have this right here. And then I have 9. So 4, 5, 6, 7, 8, 9. And they're at 3. I might be off just a little bit. It's a little bit harder to eyeball this. So I got this, and then I have one at 2, and then it's like negative square root of 2. Square root of 2 is between 1 and 2, and it's negative, so I want to roughly say ballpark it about in this area right here. All right, so I can kind of see that I'm predicting some type of graph that looks like this. This right here is actually called a hyperbola. It's basically a sideways parabola. All right, so there's that. Let's do one more of these. I want to make sure you have plenty of examples. So let's look at number 30. All right, so we have 5x minus 2 equals negative y. So we have a table, x and y. We have don't know and 0, 0 and I don't know, 1 and I don't know and 7, negative 2 and I don't know. All right, so do this first one here. This would be 5x, because I don't know my x, equals 0. So then I just solve. So plus 2. So I get 5x equals 2 divided by 5. So x equals 2/5, 0.4, however you want to write it. So then I try the next one. So this one's now 5 times 0 minus 2 equals negative y. I guess I should have clarified that. That should have been a negative 0, but it's still just 0. So this would be 0. So I get negative 2 equals negative y. So that means positive y equals positive 2. We try the next one. So now this is going to be 5 times 1 minus 2 equals negative y. So this ends up being 5 minus 2 equals negative y. So this is 3 equals negative y. So if negative y equals 3, that means positive y must equal negative 3. All right, so we try the next one. So again, this would be 5x minus 2 equals negative 7, because again, the negative is part of it. So then I solve for x this time. So 5x equals negative 5 divided by 5. X equals negative 1. And so then I get 5 times negative 2 minus 2 equals negative y. So this is negative 10 minus 2 equals negative y. And then this gives me negative 12 equals negative y. If negative y equals negative 12, then positive y must equal positive 12. So now let's graph this and see what's going on. So we get 2/5. So 2/5 we're going to say is about right here and 0. Then we get 0 and 2. It's about right there. Then we get 1 and -3. So that's about right here. Then we get -1 and 7. So 1, 2, 3, 4, 5, 6, 7. And then we get -2 and 12. So 8, 9, 10, 11, 12. Something like that. If we had sketched that, I'm definitely assuming this is going to be some type of linear line. All right. Hopefully that was enough with those type of examples. I just want to make sure you had plenty. So let's look at number 33. 33 tells us to find the distance between the two points and find the midpoint of the line joining each pair of points. All right, so we have -2 and 3, and -5 and -2. So again, to find the distance, so this is part A, I'm going to take the square root of the difference of my x's. I'm not even going to sweat labeling it. I just know I need to take the difference of my x's. So do notice this is minus a negative squared plus the difference of my y's. So again, 3 minus -2 squared. Again, I think the formula is x2 minus x1, but it doesn't matter when you square it. So two negatives do make a positive. So -2 plus 5 gives me 3 squared. 3 plus 2 gives me 5 squared. Notice if I would have switched that, that would have been -5 plus 2, which would have been -3 squared. And then -2 minus 3 would have been -5 squared. But regardless, when those are both squared, I would still get 9 plus 25. And then that right there gives me 34. I'm curious if they want you to simplify. No. I think they do want you to simplify if you can, but this is 2 and 17, which can't go any further, but they do want to simplify those radicals. Part B wants you to find the midpoint. So remember the midpoint, I'm just going to add the x's. So -2 plus -5, divide by 2. And then this is 3 plus -2, divide by 2. So -2 plus -5 is -7 divided by 2. 3 plus -2 is 1 divided by 2. So there is your fractions. So I believe what is 3? Again, keep it as a fraction, doesn't matter. And that's pretty much it. Oh, it does have one word problem in there. So let's talk about it. So I want to jump to number 57. All right, so it says your backpacker's guide contains a grid map of Paris. Each unit of the grid represents 0.25 kilograms. Oh, I lied. That's kilometers. If the Eiffel Tower is located at -8, -1, and the Arc de Triomphe is located at -8, 4, what is the direct distance, not walking distance, which would have to account for bridges and roadways, but between the two monuments in kilometers? The first thing you gotta do is figure out what the distance is. So again, I'm gonna take the difference. So it's gonna be -8 minus -8 squared plus -1 minus 4 squared. So this is a positive. So a -8 plus an 8 is 0. So this would be 0 squared. -1 minus 4 would be -5 squared. So then I would get 0 plus 25, which is just square root of 25, which is just 5. 5 is not the answer. Remember, each unit represents kilometers, 0.1 kilometer. So I got to then take this result and multiply it to the 0.25, which I think gives us 1.25 kilometers. So from the Eiffel Tower to the Arc de Triomphe, it is 1.25 kilometers as the way the crow flies. So you don't have to worry about bridges or roadways, a straight path. All right. And so that's about as hard as those word problems got. Other than that, that's pretty much it on 3.1. So if you need any more help, just reach out and let me know. Other than that, I will see y'all in the next video. Bye for now.